Chapter 5, Section 1. Nth roots and rational exponents. We have talked previously that roots and exponents are opposites, like add and subtract are opposites, and multiply and divide are opposites. To the and then the root of are opposites. And this just goes into more detail about how and why that is the case, and other ways to write a root. A root can be written as a rational exponent or a fraction exponent. If you're doing an nth root and n is an even integer, so you're doing, an even root of a number, a square root, a fourth root, a sixth root. If the number you are rooting is below 0 or negative, you can't have any real ones. If it's a 0, you get one answer, 0. And if it's greater than 0, if it's a positive number, you get two answers. Whenever you do an even root, you get plus or minus. If you're doing an odd root, you always get one answer, either a negative, 0, or a positive. However it starts is how it finishes. So find the indicated real nth roots of A. So what they're asking us to do is take the A that they give us and find the nth root, which basically means find the nth root of A. Those are the same thing, whether it's to a fraction or in the radical sign. The root number of the radical, the index, is the denominator of the fraction. Okay. So find the indicated nth roots of A. So we've got negative 216, and we have to find the nth root, or we need to find the third root of negative 216. Odd roots end like they finish, so we know it's going to be negative. And then we just have to figure out what goes into that many times. Let's see, 216. Well, I know 2 does. Half of 200 is 100. Half of 16 is 8, so that's 108. Let's see, that would be 12 and 9. 9 is 3 and 3. 12 goes to 4 and 3. 4 goes to 2 and 2. We got 3 2s. We got 3 3s. A 2 comes out, a 3 comes out. 2 times 3 is 6. That's how you do it without a calculator. We can always check the calculator to confirm. We can say wrong button. Got to go to Funcs, MISC, and then you're going to do the nth root button. We're going to do the third root of negative 216, and it's negative 6. It works the same if I do negative 216 to the 1/3. The third root. They mean the same thing. Okay. Now let's look at how that works if I take the parenthesis off. If I delete that parenthesis. Luckily enough, Desmos still gives us a good answer for that. But be careful with those, especially even roots, if you're going to use the calculator. Put a parenthesis around your A. All right, 81, and we're going to do the fourth root, which is the fourth root of 81. So I'm looking for groups of 4. So that's 9 times 9, which breaks into 3 and 3 and 3 and 3. There's 4 3s, so it's plus or minus 3. Remember, you get both kinds, especially when we're doing the root to solve an equation. Evens are plus or minus, odds end like they start. So find the indicated nth roots of A. These are without a calculator, so try and do it without a calculator. Remember, what they're looking for is A to the 1 over n, or the nth root of A. Try them on your own, come back, see what the answers are. Let's look at number 1. 16 is my base, and I'm going to do the 1/4. So I can break that into 8 times 2, and that's 4 times 2, and that's 2 times 2. Those are all broken, and I got 4 2s, so plus or minus 2. Even root, plus or minus. All right, number 2. We're going to do negative 49, and we're supposed to do the half which is the square root of negative 49, which is no real roots. We could get 7i, but we can't get any real roots, so it'd be no real roots. Number 3, we want to do negative 125, and we're going to do the 1/3 root. So ends like it starts, and that's 5 times 25, and that's 5 times 5. And we got a group of them, so negative 5. Black, why not? And we'll do number 4, 243. And we're supposed to do the 5th root of 243. Let's see. What goes into 243? 2 plus 4 is 6, 7, 8, 9. 3 does. 3 goes into 24, 81 times. That's 9 times 9. That's 3 times 3 times 3 times 3 times 3 times 3. It's 5 3s, so it is 3. Rational exponents do not have to be in the form of 1 over n. You could also have some other number, like if it was 3/2 or negative 1 over 2. That doesn't have to be positive. Okay. So we've got a rational exponents property here that we can look at. If you have something like a to the m over n, you can separate it into a to the 1 over n times the m. So you can take the numerator off as an exponent, take the denominator off separately as a root, and you could change it into the root of a and then to the exponent. If you throw a negative on there, it brings in that negative exponent rule where you reciprocal, you flip it over, or I like to think of it just jumping that divide line, because everything else stays where it is. It's just that number gets to move on the other side of the divide line. So, evaluate the expression. What I would do here is I would turn it into 16 to the 1/2 to the 3rd. I do the root first because if I shrink the number, it's a lot easier to then exponent the number. If I try to exponent it first, make it huge, and then I got to shrink it, it gets even weirder. So I don't want to do that. I'm going to shrink it first. So I'm looking for square root of 16 to the 3rd. Square root of 16 is 4. 4 to the 3rd is 64. 32 to the negative 3/5 is going to, if I do my divide line, it's going to jump. So that's 1 over 32 to the 3/5. So that's 1 over the 5th root of 32 to the 3rd. Let's see, 2 times 16, 2 times 8, 2 times 4, 2 times 2, 1, 2, 3, 4, 5. 5 2s. So it looks like we have 1 over 2 to the 3rd. And 2 times 2 is 4, times 2 is 1 over 8. 1/8. You can also use a calculator for things that aren't going to go nicely and approximate what that would be. So evaluate each expression using a calculator. Yay! But remember, when you answer, you have that squiggly equals, because we're going to round to 2 decimal places. They'll tell you where to round it. So on A, let's have a look. Let's see, 9 to the 1/5. So that is approximately 1.55. We're going to round to that decimal place. Let's look at 12 to the 3/8. 2.5. The 3 is going to go up because 9 is 5 and above. Give it a shove. So 2.54 approximately. Okay, slide that over there. And they want us to do parenthesis, go into funcs, the nth root, the 4th root of 7 to the 3rd. It's approximately 4.30, because the 3 makes it stay where it is. That's what it takes to do it with a calc and approximately. All right, evaluate the expression without using a calculator. So The first 4, do it without the calc. The next 4, do it with the calc. Give it a try, come back, see the answers. Let's look at number 5. 4 to the 5 halves is 4 to the 1/2 to the 5th. 4 to the 1/2, which is the square root of 4, is 2. And 2 to the 5th is 32. Number 6, 9 to the negative 1/2 is 1 over 9 to the 1/2. 9 to the 1/2 is the square root of 9, which is 3, but remember, plus or minus. Okay. Number 7, 81 to the 3/4, which is 81 to the 1/4 to the 3rd. Let's see, 9 times 9, looking for groups of 4, it's 4 3s. Okay, so we got plus or minus 3 to the 3rd. So we're going to get plus or minus 27. Probably just 27. Usually when you're doing it in these things, when you're just expressing what the answer is, you're just simplifying, you don't normally worry about the plus or minus on the even roots. But when you're solving, you got to make sure you plus or minus. So it's probably just 27. Same thing back here with the 1/3. It's probably just positive 1/3. But just to be safe, might as well do them all. All right, let's look at number 8. 1 to 7/8. Doesn't matter. 1. The only way to get 1 is to multiply it by itself. That's going to be 1. Maybe it's plus or minus because you do an 8th root and then you do 2 to the 7th. But it's 1. Now, let's try 9, 10, 11, and 12. Those bad boys are easy. Calculator. Now, the other thing about those top ones, even though it says without a calculator, you should probably show your work on that. When it comes to a test, use a calculator. It's way easier. All right, 6 to the 2/5. So this one is approximately 2.05. As the 7 is 5 and above, give it a shove. 64 to the negative 2/3. Approximately 0.0625. Now we're supposed to round to 2 decimal places when appropriate. So I've got 1, 2, 3, 4 decimal places. The reason I'm not doing the rounding here is because it actually stops. I could turn that into a fraction. It's 1/16. It's not that bad, okay? So I would leave all the decimal places on that one. Parenthesis funcs 4th root of 16 to the 5th. 32. We don't even have to round. We know it's 32. Okay? And in fact, it just equals that. Didn't even have to do that one on there. And number 12, I could just do it this way. But let's see, funcs int 3rd. Oop, forgot the parenthesis out there. Negative 30. Out there to the 2nd. Approximately 9.65. That one does need a rounding. It's a bit weird on the wobblies there. There we go. You could also write that as negative 30 to the 2/3. We could change that radical into an exponent by making it the denominator. Okay? To solve an equation of the form something u to the n equals d, where u is an algebraic expression, take the nth root of each side. So basically, get the exponent part in outside the parentheses, so everything that has the exponent attached to it by itself, and then do the nth root of both sides and solve. Switching back to red. So let's look at A. You got 4x to the 5th equals 128. Well, x to the fifth, the only thing to the fifth in this situation is the x, because the 4 and the x are not in parentheses together. So get rid of the 4 first. X to the fifth equals, let's see, 3 and 32. And then we're going to fifth root our answer, so x is 2. And I know it because we've done it a bunch of times. Let's look at B. X minus 3 to the fourth equals 21. So we're going to fourth root both sides. So we get x minus 3 over here equals plus or minus whatever the fourth root of 21 is. There isn't one. It doesn't say to round our answer, so we're just going to do it in the best way possible. Because 21 divides into 7 and 3. There's no 4 of anything, but we add the 3 over. So x equals plus or minus the fourth root of 21 plus 3, where we have to do both answers, positive and negative, because it's a fourth root. Okay. Word problems. Real life application. A hospital purchases an ultrasound machine for $50,000. The hospital expects the useful life of the machine to be 10 years, at which time its value will have depreciated to $8,000. The hospital uses the declining balances method for depreciation, so the annual depreciation rate, R, in decimal form, is given by this formula. In the formula, N is the useful life of the item in years, S is the salvage value in dollars, and C is the original cost in dollars. What annual depreciation rate did the hospital use? So what rate? We need to find R. 1 minus, and it's a fill-in-the-blank problem. So the S is the salvage value, which is $8,000. The C is the original cost in dollars of $50,000, and those zeros don't matter, so it's 8 divided by 50, which is 4 divided by 25. And then we have to do the useful life of the thing, which is 10. And so they want us to find R as a decimal. So let's do it. 1 minus parenthesis 8, 1, 2, 3, divided by 50, 1, 2, 3, to the 1/10. So 0.17 if we're rounding to 2 decimal places. They didn't tell us where to round, so we can pick that many. But that's this rational root stuff. The fractional ones are roots. The denominator is the root you do. The numerator is the exponent. Find the real solutions of the equation. Round your answer to 2 decimal places when appropriate. So try 13, 14, 15, 16. And 17 uses that same equation, except they changed the value of the salvage value. So just plug that other one in. Try them right now. Come back and see what happens. All right, let's look. 8x to the third equals 64. You get the x to the third by itself, so divide by 8. X to the third equals 8. Third root. X equals, let's see, 2 and 4, 2 and 2, 3 2s, x equals 2. Let's try number 14. Didn't mean to pick purple first, but whatever. 1/2 x to the fifth equals 512. Get rid of dividing by 2 or getting rid of 1/2 is multiplying by the reciprocal, so we're going to multiply by 2. So we get x to the fifth equals 1024. And we're going to take the fifth root. So x equals, and let's see. Well, divided by 2 we know is 512. Divided by 2 is 256. Divided by 2 is 128. Divided by 2 is 64. Divided by 2 is 32. And 32 has 5 2's in it. So we need 1, 2, 3, 4, 5 2's. 32 I know has 5 2's in it. 1, 2, 3, 4, 5. So 2 2's come out. So not plus or minus because it's an odd, but 4. Okay. Here we go. Green. Let's see. 15. X plus 5 to the 4th equals 16 to the 4th root. X plus 5 equals plus or minus 8 and 2, 2 and 4, 2 and 2. There's 4 2s, so 2. And then subtract 5. I don't like that. I'm going to write it underneath. So 2 minus 5 would be -3, and -2 minus 5 is -7. 2 different answers there. Let's do 16. X minus 2 to the 3rd equals -14. Square root. No, not square root. Cube root. X minus 2 equals the cube root of -14. It doesn't have one. Add 2. So x equals the cube root of -14. And then when we write this, the hard part with it, see if we do cube root -14, make sure your plus 2 is on the outside. You could also write it as 2 plus the cube root of -14. That would also work. Okay. And then 17, what if we changed it? Well, let's go back and look at that equation real quick. I'll pick black this time. 1 minus s over c to the 1/nth. Okay, so 17. 1 r equals 1 minus, our new salvage number is 6,000 over 50,000 to the 1/10th. And I'm just going to go back in here and change it to 6 and 0.19. The rate is about 0.19. Just change the one piece out that they changed. And that is nth roots and rational